I recently received some feedback from a student and it got me thinking. So I was in the bath and I came up with this idea that we would go through an exercise whereby we would try and decide the type of relationship between the tables. So if you are at that point where you are currently trying to decide or work out or learn the different types of relationships that we can make between tables, then this tutorial is for you. So first of all, let's talk a little bit about the different types of what was commonly known, I say commonly, which can be known as association mapping. So here we can map tables together. We're going to build relationships between tables, and we can say that the mapping options that we have available are many to one, one to many to many, and one to one. So here I'm using the set of tables from the e-commerce version 2 series, and we're going to go through each table. I've removed the keys from each table, and we're going to go through this step by step, have a look at these tables and just discuss what relationships we can develop between these tables. So maybe the first question that needs to be answered is, what's the point of creating relationships between tables? So here in Django, we are in the realm of relational databases. So data is related to other data. So from one table, there is a relation from this table maybe to this table here. So by creating relationships, we can control the data that can be stored in a table, for example. We can utilize relationships to control the changes to the data. And we're working towards the idea of data integrity. So the overall accuracy, completeness, and consistency of our data within our database. Now, if you understood anything that I've just said there, then this tutorial is probably not for you. So let's move into the main content here and let's start to discuss relationships. And I'll bring in all that other information I just mentioned as we go along. So we need to decide whether these two tables have any relationship and whether they need to be associated and connected together to build an association mapping. And then we need to decide whether we should have a many-to-one, one-to-many, many-to-many, or one-to-one connection or mapping between these two tables. So the first question, is there an association between product and category? So the answer to that is yes. So here I'm thinking about my business case. I'm thinking about what I'm trying to store. I'm not trying to bring any theory in here at all. I don't need to do that. I just need to think about how my system works, how I want my system to work, my application to work, and how that data is related to these tables here. So when I add a product to my database, I want to associate my product to a category because I know later on down the line, my application is going to provide the customer the ability to retrieve products by category. But we can just simplify this and just say, well, a product is part of a category. You know, it's going to be related to a category. So there is some form of relationship there. So now we've established that in a very unscientific way, then we can now start to think about our association mapping. So what kind of connection should these two tables have? So let's now decide on the connection between these two tables. Right. So we're going to start with one table, and then we're going to discuss the relationship to the other table. And then we're going to go from the other table and discuss the relationship to the other table. And then by doing that, we'll be able to work out what type of association to provide these two tables. Okay, so for one product in our system, our product must be associated to how many categories? So this is completely up to you, and depending on how your application is meant to be developed will depend on the relationship in this case. So in my scenario, maybe one product is only connected to one category. Maybe in your application, one product needs to be connected to multiple categories. So you may have a product or whatever it is here, product or whatever you're modeling. It may have the ability to be in two categories or part of two categories. So for example, if you had a product here, a TV, it might be part of the electronics category, and it might also be part of the TV category. So what we have here then is one product is associated to many categories. So I'm just going to represent that relationship here for one product is equal or is related to many categories. Right, so now we're going to do the exact same thing again, go through the exact same process, but we're starting off with the category table. So in this case, we're now going to say one category, start with one category, that is associated to how many products, one or all or many. So we just need to decide that. And again, that might be down to the business logic of your application. It might be depending upon how your application works or how you see your data related to the product table. So one category could be associated to one product. Now, that's probably not the best way to work, because if you've got 1 million products, you then need 1 million categories. So that probably isn't going to be the way forward here. So one category is associated to many products. So here we now have a one-to-many relationship. So in this case, what we need to do now is just take this information here, and this then will be able to determine what type of relationship we now have between these two tables. So because there's a 1 on the left-hand side and a star here, many, we're going to bring down the star. And then because there's a star over this side as well, we're going to bring that star. Oh, this is a weird... It's bizarre. When I press star and space, it then turns into a circle bullet point. Of course it does. Right, so let me just work this out. So star, star. There we go. Right, so what we have now is a many-to-many relationship. So let's look at this slightly differently. Let's imagine that in actual fact, our system or our application worked in that one product was only associated to one category. So let's imagine that was the case. So in this case, we would have a 1-to-1 connection from product to category. Okay, so this is a slightly different business case in this scenario. Right, so now we do the category to product. Well, that's going to be very similar to what we had before, because one category is going to be related to multiple products. So let's go ahead and bring that down. Okay, so now we've worked out the relationship between these two tables. We can now do the maths here, right? So there's no real maths here, but all we need to do is bring down the stars. Okay, so here we have, I'll just copy and paste this. So on the left-hand side here, we have a star, and on the right-hand side, we don't have a star. So therefore we add the 1 here, right? So what we have now between the product and the category table is we have a many-to-one connection. So just before we move forward, I just want to establish this. Apologies if I'm just embellishing too much here. So in the first solution here, our application needed a setup whereby there was one product and it was associated to multiple categories. That's just how we wanted to work. And then we decided that one category was actually also associated to multiple products. So we use the 1 to stars to represent that. Now, we then take this equation and we can take the stars and bring them down. So we looked for the stars first, and then we worked out that the relationship between product and a category table in this scenario at the top here was a many-to-many relationship. So we then looked at a different scenario whereby in actual fact, in this scenario, our product is only associated to one category. So we did that first 1-to-1, and then we established that there was a 1-to-many relationship. So one category was associated to many products. And then we did the equation again. So any stars we bring down, and then on the right hand side here, you can see there are no stars. So we bring the 1 down. So what we have now in this scenario is a many-to-one connection. So let's talk a little bit about how we can then go ahead and define this in Django, and also the behavior, the default behavior of Django when working with many-to-many relationships. Okay, so let's discuss the many-to-one first. Right, so let's presume that we go with scenario 2 and we decide that one product is associated to one category and one category is associated to many products. So let's go ahead and just draw this out. Now, The first thing we're going to need to do is we're going to take this side of the many and we're going to add in here a new row. Okay, so this is going to be the foreign key. So the foreign key represents data that can be found in a category. It's like a reference point to the category table. So we're going to call this category, and this is going to be a foreign key in our table. So whenever we enter data into the product table now, by default, we have to include a reference to an entry that exists in the category table. So we can see here, going back to what I initially said at the start of this tutorial, that the foreign key, or the constraint here, the foreign key constraint, controls the data that can be stored in the foreign key table. So that's interesting. So what we've done here is, if we built this in Django, is that we couldn't actually add a product to the product table unless we have a valid reference to an existing category that exists inside of the category table. So what's going to happen here is that we need to add a category into the category table. That category is going to have an ID, a unique ID, a primary key, and we're going to use that primary key to build a reference from the product over to the category table. So what we have now in the product table when we add a product is we have a reference to the category. So let's go ahead and query this product table. If we were to query this product table, the data that we return, we would be able to determine, based upon the category ID here in the foreign key, what category a product is related to. Because all we need to do is get the data from the product table, work out what the category ID is for that particular product, use that ID, and then work out what category that is associated to. Because the ID here in the category foreign key table field, it should relate to a category that's stored inside the category table. So let's go ahead now, and remember, this is the any side of the relationship here. So we go and build this relationship here. I will do it the other way around because then I don't have to do the changes. So you can see that in our diagram here, typically the side of the many has this crow's feet. And then on the right hand side here, you can see the slash here representing 1. So here we built a many to one relationship. So a common question that might be asked at this point is, well, don't we need to do anything in the category table to indicate that the category table is connected to the product table? So the answer to that is no, you don't. So let's not forget there is an artifact here. There is a reference to the category table. So if we did want to query from the category table over, we can still do that by utilizing the category foreign key in the product table. So let's imagine we wanted to return all the categories associated to product ID 1. So what we would do here, we could run a reverse foreign key lookup starting from this category table. So we're going to return all the categories associated with product ID 1. So we would go ahead and run a query on this table. We could then use this connection as a reverse foreign key, go ahead and grab the products, and those products would have a category ID. So we would grab all those IDs and match them to the categories that are stored in the category table, thus returning all the categories then that are associated to those products. So I do apologize. That's a little bit harder to understand. I've kind of fallen into a trap there, potentially. So I've already said too much already. That is pretty much all I wanted to say about this foreign key situation here. Hopefully now you've got a general idea of how we've generated this connection and how we've determined which side should have the foreign key reference. So let's now talk about the other scenario here. the many-to-many situation in Django. So this is a fairly situation to set up. In our model now, we would define a foreign key, go ahead and do that, set category, and that's pretty much all we need to do at that point. So something else I didn't mention that's probably worth mentioning here. So I also mentioned at the start of this tutorial that the constraint can control the changes to data in the primary key table. So what I mean by that is this: if we develop a foreign key relationship, remember what we said here, that in order to build this product, we need a reference point over to the category table. Now, if there wasn't any categories, we could argue that there is no need for any products, because we've set up a constraint here that says that if we do have a product, it must have a category. So one thing to look out for in Django is the onDelete attribute that we can define when generating a category foreign key. If you look at the course, if you look at this channel, you will find I'll put it in the video description. There is a tutorial which discusses this in more detail, all the different options for the onDelete. So we can set this up so that, for example, if we did delete a category, it would also delete all the correlating products or all the associated products to that particular category. Now we can change that, and we can set the onDelete attribute to perform other actions should we delete the category that's associated to this foreign key. But if you think about this, if we did delete a category, say category 1, and retained all the products, what we would have is an issue with our data, because we would have a product that has a category 1, but that number doesn't relate to anything in the category table. So we have inconsistent data at that point. Okay, so maybe I've said way too much, but maybe that was also useful for you to think about as a kind of a reference point, a starting point there. Right, so let's talk about the many-to-many. So I'll just remove this link here. Right, so many-to-many, we've worked out many-to-many. So let's go ahead and build our many-to-many. So first of all, let's just remove this field. Right. Okay, so let's build a many-to-many. So the first thing to consider is, well, which side should we define the many-to-many relationship? So this is what I'm going for. Can we have a category? Can we define a category without defining a product? Yes, we can. So we can build a category without it being dependent upon a product. But can we build a product without a category? The answer to that is no. Therefore, category is not dependent upon product, but product is dependent on category. So I'm going to define the many-to-many field in the dependent, I think it's right, the dependent table. So the table that depends on the other table. So that's where I'm going to place the many-to-many field. Right, so that's how I worked that out. Very scientific there. Insert row below, and let's go for category again, and then I'm going to define that as a many-to-many relationship. Good. Right, so we'll go ahead and build a many-to-many relationship. Okay, and then on this side we can change it. This is a Lucid chart. I've not used this before. So here we've indicated now through this pattern here. On either side, we have a many-to-many relationship now between these two tables. So again, at this point, it's worth noting that there is nothing we need to do here in the category table. We don't need to add a foreign key over to a product. We don't need to build that association. Now, it doesn't mean that we can't then traverse from category to product when we query across. We can do that. We can reverse. And we'll see in a second why we can do that and why there is no need for us to define anything in the category table. Now, it's worth noting that when we build a foreign key, that is an actual field that gets generated in the database. When we build a many-to-many relationship, this is not a field that gets generated in the product table. This is a reference point which can be then utilized to determine that there is a many-to-many relationship between this table product and the category table. So by default, let me just, by default, Django builds another table. So this is what's happening. When we build a many-to-many connection, Django is going to make another table. And it's going to take the names of these tables, the many-to-many tables, so product and category, and it's going to build a new table for us with a name that correlates to the product and the category table. Okay, so that's what gets generated, a new table. Now, inside of this table, just tidy this up. Inside of this table, Django will automatically create the ID, the primary key, auto-incrementing, and then it will create two foreign keys. So first of all, it will create a foreign key over to the product table, and then it will also create a foreign key over to the category table. So this is automatically generated by Django, a new table. So here we have two foreign keys. Now remember, this foreign key is going to be then a many-to-one over to product ID, and then from category to category here, the category field, is going to be a many-to-one. So what's happening here is that this new table is storing the relationships between the product and the category table. So let's try and imagine the data that's going to be stored here. So let's have product 1 and let's have category 1 and 2. Okay, so product 1 is associated to category 1 and 2. So what's happened now is in the link table here, it can be described as, in this link table here, we now have two entries, in this table, product 1 in this product number here and category 1 here. So that's the first row, first record in this table. And then we make a new record. So ID 2, we then have product 1 again, and this time category 2. So we now have in this table, stored in this table, reference to product 1 to two categories. So if we were to query this product table and to return all the categories associated to product 1, we would then query this table, we would look at this table here, we would collect all the products from this table, which is associated to product 1. So there's two entries, and we would return that. And we would find that this product 1, in actual fact, there was two entries here, and it's associated to two categories or more. So it's important to remember that there is no need for us to create a foreign key or any relationship back to the product table through the category table. We could start at the category table and query it. Again, we could query across the table if we wanted to. So we could work out, for example, all the categories that were associated to product 1, 2, and 3, for example. So that's the default behavior with Django when we generate a many-to-many connection between two tables. Now, there may be occasions where you would like to generate your own link table. And the reason why that might be, one of the reasons why that might be, because there might be data in here that you want to order. So if you wanted to return this data for some particular reason and you wanted to order that data, you may want to add custom fields here. Now remember what Django is doing behind the scenes, it's just making this table here. It produces a foreign key and a primary key, and then it produces two foreign keys related to the two tables that has a many-to-many relationship. If you take a look at the Django documentation, it does take you through the general process of building your own link table here when defining many-to-many relationships. So far then, we've seen the many-to-one, one-to-many type of relationships, and then also many-to-many. So there are a few more tables for us to take a look at. So let's now just apply this knowledge directly to those tables. At this point, there isn't too much more to talk about because we are literally just generating now the same relationships between the other tables. There is one occasion where we use a one-to-one, and I'll explain that as we go along. So next up then, we have the media and product table. Right, so you can already tell that I've already decided that there's a relationship between them because each product potentially is connected to some sort of image. So there is a relationship between the product and an image. Now, this particular database is slightly different, and it does cause maybe some difficulties understanding, but how this is set up, let me just quickly explain. So this database here, we store the product. Now, imagine we are actually building a database to actually store all the information about the actual products that we're storing in our warehouse. So if we were storing, for example, clothes, then clothes come in different colors, shapes, sizes, right? So we would need to store information about the product, and then potentially we would need a product inventory table. And in that inventory table, we are storing every single product that we have stored in our actual warehouse. So all the product 1, ID 1, the red version, the blue version, the size 10, the size 11, and so on. So this table stores all those kind of details there. So there is a relationship here then between the product and the product inventory table. So we just need to work this out first. Okay, so let's just go through the same process again. One product in the product inventory. How many products is that related to? Well, for one product in the product inventory, say the red shoe, that is related to one product. Okay, so what we have here then is a one-to-one relationship from the left to the right. So for one sub-product, if you like, it is related to one product. So one product on this side is related to potentially many products, sub-products. So one product, then maybe the red one, the blue one, the pink one, the green one. So we're going to store that information in separate records or rows in the product inventory table. So here we have a one-to-many relationship. So what we end up with then is what we saw over the other side. So we just do the maths down. So the maths. As we do the equation, we can see here that we have a many over this side, so we bring the many down, and on the right-hand side are all one, so we bring that down. So here we have a many to one. So let's just follow the rules that we generated. The many side will have the foreign key. So let's go ahead and insert the row below. We're going to call this product. Now, by all means, if you get this, there's going to be a little bit more of this. If you already understand this, then the only thing that we have left is the one-to-one. I'll do that next. And then if you feel comfortable, then you can leave. You can leave. You can leave the class. So we add the foreign key here. So this is going to have the foreign key connected to the ID of the product. No idea why it does that. Oh, useless. Okay, wonderful. Why is this useless? Oh, there we go. Right, so let's just change these links around. So many to one. There we go. Let me just see if I can suitably find a position for that. There we go. Right. Okay, 1 second. So we've got many. Yep, many to one. Okay, one. There we go. Right, so that's the relationship we built. We now go ahead and add the foreign key in the product inventory table in our model, and then we built the relationship across. Cool. Right, so that's that completed. So let's move on now to the media. Oh no, we're going to do the one-to-one first. So by my reckoning, our products in the product inventory, our sub-products, we need to record whether there is any stock at all. Now, we could have the amount of units inside of this table, for example, because the product inventory is associated to the units sold, and maybe the units as well. So why this table has actually been formed is a little bit out of scope of this tutorial. So let's just go with it. There is a stock table. The whole point of the stock table is I can determine when the product was last checked, physically check to see if the stock that we have in this warehouse equals the stock that's currently on the system. So a bit of kind of stock control there to see if any of the products have been damaged or whether they've been stolen and so on. So what's the relationship here between the stock table and the product inventory table? So it may not be very clear if you don't fully understand the scenario. So one stock item, one entry, one row, one record in the stock table should relate to one product or subproduct here in the product inventory table. Right, so that's the deal there. So we're saying that, there's one entry in the stock table recording the units sold, and that's related to one subproduct, the red shoe, the green shoe, the blue shoe, and so on. Right, so one subproduct here is related to one entry in the stock table. Okay, so now you can see we've got a one-to-one relationship. So we just bring those numbers down, and then we've got one on the left-hand side and one on the right-hand side. So therefore, we now have a one-to-one connection between the stock table and the product inventory table. So in Django, we need to work out which side should have the one-to-one relationship. So we just need to ask ourselves again this idea of dependency. So could the stock table exist if the product inventory table didn't? And the answer to that is no, because we'd be recording units and units sold related to absolutely nothing. So the stock table could not exist if the product inventory table didn't exist, whereas the product inventory table could exist if the stock inventory table didn't. So we can still store data in here. So therefore, the one-to-one relationship is going to be based upon the stock table. We're going to insert it into the stock table model. So let's go ahead and insert the row below, and then we'll just add that in. So I'm just going to call it product inventory, or product. I'm just going to call this subproduct. It doesn't really matter. So subproduct. Okay, so that's going to be our one-to-one connection. So we're then going to build that across over to the ID of the product inventory. Oh dear. Okay, there we go. So let's just update that. And then we have our one-to-one relationship. Okay, you can see there's a few more fields here. Feel free to leave this class if you've got the general idea. There's no more additional information here. We're just going to look at these other tables and now just determine the relationships. Right, so back over here then. So I am obviously skipping a few steps here in terms of I already know what table's connected to what. So we can go through that process, of course. Is the stock table associated to the media table? No, there's no connection at all, right? So we can use our instincts here. We know that this media table is going to store images. What's the images associated to? Well, the products. So should it be associated to the product table? Yes or no? Well, no, because for example, your product that you might be associating the media to might be the red shoe. Now this in here in the product table doesn't map or doesn't correlate to those subproducts. So therefore it's difficult to map the image, the red shoe image, to the product, and then the blue shoe image to product. So we can instinctively maybe decide that the media table is connected to the product inventory, the subproducts. Here we have all the products, all the subproducts, all the colors, all the shapes, all the sizes. Now, each one of these products will need individual images. So that's why it's going to be connected to the media table. So now we just need to work out the relationship. Right, so for one media, for one image, it's going to be associated to how many subproducts, one or many. Okay, again, this is where we need to decide, or you need to decide in your application, how this data is going to be modeled. Because depending on how you want to set up your application will depend on the connection here. So what we will find in this scenario is like we had it with the product and the category, it can probably be both. So let's just model this first. So we could say that for one image, that could be used in multiple subproducts, maybe. I say maybe. And then for one subproduct, it might have many images. So we might have 4 images of each product, for example, different angles of the product. So therefore, what we have is a many-to-many relationship between the media and product inventory table. So in this case, we now need to determine which side should have the reference. So can the product inventory table exist without media? Yes, it can. So it's not dependent upon this table. Can media table exist without the product? well, no, we can't really add information into this table because it doesn't relate to anything. So it's kind of pointless. So it is dependent on the product table. So because it's the dependent table, because it depends on another table, the adjacent table here, we then decide that is going to then have the many-to-many reference. So we just go ahead and product inventory, and we set that up as the many-to-many field. And then the exactly same process happens there. If we use the default settings in Django, Django will create a link table between the two tables, and that's how it's going to be defined. So let's imagine the other scenario, and that's what we're going to go for here. So for example, one image is associated to one subproduct. So only one image, and that probably makes more sense here because the red shoe image probably isn't another red shoe exactly the same, because it's going to be different brands and so on. So it probably makes sense in this scenario that there is a one-to-one connection from media to product inventory table. And of course, on the way back, one product here in the subproduct table, it might be associated to many images. So here we have this situation over here again, where we have a one-to-one and then a one-to-many. So we end up with a many-to-one. Okay, so we know where the many is. So the many is going to be then the table that we utilize. So we apply the foreign key. So let's go ahead now and apply our foreign key. Okay, so that's going to be then connected to the product inventory table. I'm just going to add it here, for example. It doesn't have to be associated to or adjacent to the field. So I'm just going to add it across so we can see it. So here we just need to go the other way. There we go. Okay, so here we have a many to one relationship. Our foreign key has been set, and there we go. So that table connection or relationship has now been defined. So we're going to stop there. There were some more tables, but I think we've hopefully got the general idea now. The other tables were a little bit more out there in terms of trying to explain the reasons why they exist in the first place. So hopefully that was useful exercise to go through. Hopefully that's given you some insights. Now, I'm not pretending that's the most rationale, scientific way of actually determining the relationship between tables. And of course, I'm inferring many things here that you've created your tables. You can see how quickly it took me to kind of work out the relationship between tables, or whether there was a relationship at all, because I instinctively understood and knew and built the set of tables myself. So I knew already what tables needed to be related. Of course, when we're building a set of related tables, there's many different steps and there's many different approaches to take in order to actually build this set of tables. So if you are interested in learning a little bit more, I did make a tutorial not too long ago from this tutorial. It's in the e-commerce version 2 series. The first tutorial, we actually kind of build from scratch, and I go through utilizing a theoretical, an academic's base, or a known process in order to actually generate these sets of tables, going through looking at the dependencies, looking at the fields and where the fields should go in which table, generating the separate tables, and then deciding on the different relationships. So thank you very much for listening. Hopefully, again, there was some value there for you. Be worth getting some feedback if you've got any feedback for this tutorial. I'd love to hear if it was valuable or not. The only way I'm going to know whether it was of any use is to get feedback. I could make tutorials every day, all day. But yeah, unless you actually tell me it was any value, it's hard to know. And it does help drive tutorials on this platform, in this channel. Like I said at the start of this tutorial, the only reason I came up with this tutorial is because I had a conversation about some feedback. And in addition to that, I did also have some other interactions and saw some code. And I thought, well, actually, this would be maybe quite useful. Normally, if one person needs this type of support, there's bound to be more. So it's always valuable to generate sometimes a small tutorial and sometimes like this one, a little bit longer.